Hey guys, so we're going to start out with a review of prime factoring, which we're definitely going to need for today's lesson. So if you need to rewatch the video from yesterday on prime factoring, you probably should pause this now and go back and do that, because you do need to know how to do prime factoring in order to complete everything else from here on out. Okay, so go ahead, you should get a pop-up window now to find the prime factors of 42 and 108. Okay, and if you've answered the questions, let's go ahead and do the prime factors of 42. Well, the first thing I want to do is write down my important numbers, 2, 3, 5, 7, and 11. Okay, so we'll write down 42. Okay, the smallest number, or any of the 5 numbers that go into 42, we'll say, let's go with 2. 2 goes into 42 21 times. Okay, and then the next one, we can use 3. 3 goes into 21 7 times. And since 7 is a prime number, we're done. The prime factors of 42 are 2 times 3 times 7. All right, now let's find the prime factors of 108. Don't really know which number I can use for 108, but since it's even, I know I can use 2, so let's go with that one. 2 goes into 108 54 times, and again I can use 2. 2 goes into 54 27 times. Can't use 2 anymore, but I can use 3. 3 goes into 27 9 times, and 3 goes into 9 3 times. So the prime factors of 108 are 2 times 2 times 3 times 3 times 3. Okay, and if you wanted to write that in exponential notation, it would be 2 squared times 3 to the 3rd power. Okay, so let's talk about least common multiples for a second before we go ahead and try to find one. The least common multiple is the smallest number 2 numbers have in common. Okay, the smallest number that 2 numbers have in common. And you may have learned in middle school or elementary school that you just keep listing the numbers until you find the 2 numbers that are in common. So you probably did with 5 and 7. You would have done 5, 10, 15, 20, 25, 30, 35, 40. And then you would have done 7. You would have done 7, 14, 21, 28, 35, 42, 49. And then you would have said, okay, they both have 35 in common, and that's the smallest numbers that they have in common. And that's a pretty foolproof strategy. It works as long as you know your multiples, but it doesn't work when you have larger numbers. So that's when we'll use prime factoring to help us out to find the least common multiple of larger numbers. So if we wanted to find the least common multiple of 18 and 27 using prime factors, we would find the prime factors of 18 first. So let's go ahead and do that. The prime factors of 18 are, let me write my numbers at the top here to help me, 2, 3, 5, 7, 11. Okay, 2 goes into 18 9 times. 3 goes into 9 3 times. So the prime factors of 18 are 2 times 3 times 3. Okay, now 27. We can use 3, and then 3 and 3. So the prime factors of 27 are 3 times 3 times 3. So now that we have the prime factors for both of our numbers, 18 and 27, we can go ahead and find the least common multiple, but we have to do something first. We need to cross off the duplicates. So let's look at 18. We have 2 here. Are there any 2's and 27's prime factors? And no, there are not, so that's okay. Let's look at 3. Are there any 3's in the prime factors for 27? Yes, there are, so we'll cross one of the 3's off. Okay, let's look at the last one for 18. It's 3 again. Are there any other 3's and 27's prime factors? And yes, there is, so we'll cross that off. This leaves us with 2, 3, 3, and 3, which means if we take the 2 times 3 times 3 times 3, okay, because that's where they all came from, the product of these numbers is going to be the least common multiple for 18 and 27. Well, 2 times 3 is 6, times 3 times 3. 6 times 3 is 18, times 3. 18 times 3 is 54. Okay, and this means that the least common multiple of 18 and 27 is 54. Okay, and that's how you find it using prime factoring. This is very helpful when you have large numbers because it's not easy to write out all the multiples of 18 and 27. Okay, so let's find the least common multiple of 20 and 24. We'll start out by finding the prime factors of 20. Okay, I'm going to write my numbers at the top. 2, 3, 5, 7, 11. Okay, well, 2 goes into 20 10 times. 2 goes into 10 5 times, which means the prime factors of 20 are 2 times 2 times 5. Okay, now we'll find the prime factors of 24. 2 goes into 24 12 times. 2 goes into 12 6 times. 2 goes into 6 3 times. So the prime factors of 24 are 2 times 2 times 2 times 3. Now we'll find the duplicates. We have 2 here. Do we have any 2's in the prime factors of 24? Yes, we do, so we'll cross it off. We have 2 here. Do we have any 2's in the prime factors of 24? Yes, we do, so we'll cross it off. We have 5 here. Do we have any 5's in the prime factors of 24? No, we don't. So we don't need to cross anything off. Since we've come to the end of 20's prime factors, we can stop. Anything that we don't have crossed off becomes part of our product. So in this case, it will be 2 times 2 times 5 times 2 times 3. Okay? 2 times 2 is 4, times 5 times 2 times 3. Well, 4 times 5 is 20, times 2 times 3. 20 times 2 is 40, times 3. 40 times 3 is 120, which means the least common multiple of 20 and 24 is 120. Much easier that way than it is to write out all the multiples. Let's take a look at another. So we want to find the least common multiple of 30 and 36. So once again, we'll start out with our prime factors. So the prime factors of 30 will be, we could do 2 goes in 15 times, 3 goes into 15 5 times. So now let's find 36. The prime factors of 36, well, 2 goes into 36 18 times, 2 goes into 18 9 times, and 3 goes into 9 3 times. So the prime factors of 36 are 2 times 2 times 3 times 3. Forgot to write that. So 30s was 2 times 3 times 5, and 36's was 2 times 2 times 3 times 3. All right, so let's take a look. We have a 2 here is 2 repeated in 36, and there it is. We have a 3 here is 3 repeated in 36, yes it is. And we have a 5 here is 5 repeated, no it is not. So we will keep anything that is not crossed off, and we will multiply them. So we have 2 times 3 times 5 times 2 times 3. 2 times 3 is 6, times 5 times 2 times 3. 6 times 5 is 30, and I'll carry everything else down. 30 times 2 is 60 times 3, which is 180. Which means the least common multiple of 30 and 36 is 180. Okay? Why don't you give this one a shot? You should be getting a pop-up box for it now. Okay, so if you finished, let's take a look and see. We'll start out with our prime factors that we like to use. Let's find the prime factors of 26. 2 goes into 26 13 times. But none of these 5 numbers that we've been using goes into 13. So we need to check to see if 13 is a prime number, because if it's a prime number, we're done. We don't have to continue. And sure enough, 13 is a prime number. So the prime factors of 26 are 2 times 13. So now let's try the prime factors of 39. 3 goes into 39 13 times, and we just discovered that 13 is a prime number, so we can just stop right there. So now let's see, we have to cross off our duplicates. Is 2 duplicated? No, it's not. Is 13 duplicated? Yes, it is. So the least common multiple of 26 and 39 is the product of 2 times 13 times 3. 2 times 13 is 26 times 3. 26 times 3 is 78. So the least common multiple of 26 and 39 is 78. Okay, let's try one more. Let's try to find the least common multiple between 28 and 24. So we'll start out with our prime factors of 2, 3, 5, 7, and 11. And we'll find the prime factors of 28 first. So 2 goes into 28 14 times, and 2 goes into 14 7 times. So the prime factors of 28 are 2 times 2 times 7. Okay, next we'll do 24. The prime factors of 24, well, we'll do 2 goes into 24 12 times, and 2 goes into 12 6 times, and 2 goes into 6 3 times. So the prime factors of 24 are 2 times 2 times 2 times 3. Let's cross off duplicates. We have 2 and a 2 there. We have 2 here and a 2 there. We have 7 here and no 7s there, and we can stop now. So the least common multiple of 28 and 24 is the product of 2 times 2 times 7 times 2 times 3. Okay, we just have to work this out now. 28 times 2 is 56 times 3. 56 times 3 is 168. So the least common multiple between 28 and 24 is 168. Okay? That's it for today's video, guys. If you have any questions, don't hesitate to email me. Okay? Thank you very much.